all the formulas that we are going to study in this chapter. Okay, and with the units, the SI units of every physical quantities that is being used in this chapter. For example, if you have not been given that what is resistivity, okay, but if it is being given that something is going to have 2.6 into 10 to power minus 8, and it is written that ohm meter, so it means that resistivity is being given to you. Okay, so it is important for you that you must memorize the formulas as well as the units of each and every physical quantities that is being used here. Okay, so first of all, I'm just writing the all the formulas that are being used. The first formula is I is equals to Q by T. This is the formula for the current. Okay, are you getting this one?
Yes, sir.
Okay, the next one is the next formula is Q is equals to N into E. Okay, Q is equals to N into E. Okay, where Q is the charge, N is the number of electrons, and E is the charge of an electrons. Okay, where E is the charge of electron that whose value is 1.6 into 10 to the power minus 19 coulomb, and N is the number of electrons, and Q is, you are very much familiar, that is charge. Okay, charge. So this formula can further be written like Q. In place of Q, you can write it I is equals to N into E I T. Got it? The next formula that we used here is V is equals to W upon Q, work done upon time. Okay, and work done is also denoted as, this is work done, Q upon W upon V is equals to W upon Q, the work done upon charge. Okay, this is charge. Okay, so if I'm talking about that, this is charge and this is V. Okay, now V is equals to W is work done. The other unit for work done is energy also. The unit for work done is energy also. Okay, so it can be written as energy upon charge. Okay, so we can simply say that we can drive a new formula for this one, that where V is potential difference or voltage. Okay, voltage. Okay, potential difference. Okay, A is the energy that is also in joules. So this formula can be further written as V into Q is equals to E. V into Q is equals to, tell me, V is equals to V into
E.
Q. Okay,
Energy.
okay. So this can be written as V into Q. Okay, and this is equals to energy. Okay, got it? And this formula can also be written as, what is Q? Q is as got it? So this is the formula for the energy. Understood?
Yes, sir.
Okay. Just a minute. Just a minute. Now moving further, this is the formula. Okay, next we shall be moving to the next one is another type of formula that we're going to study here is R is equals to V by R is equals to V by I. Okay. Or we can say that V is equals to IR. V is equals to I into R. Then we can say that R is equals to V by I. Okay, this is the same formula that we're going to study. Got it? So how many kinds of formula we are going to have? I is equals to Q by T. This can be written as I is equals to N into this formula can be written like this way. Okay, and the same formula for the work done is V is equals to W by Q. V is equals to W by Q. Okay, or this W goes to this side. So this is the same formula, but sometime in the question, instead of work done, energy is being asked. Okay, are you getting my point? Since sometimes instead of work done, energy is being asked. So don't get confused that what is energy. So if voltage and potential difference is given, voltage and charge is being given to you. So they were asking you energy, and this is V into Q. Okay, V is equals to I into R. This can be written, and this is also a relationship between current and voltage. This is the next one. And after this one, we have V is equals to, I is equals to we have the next formula that R is equals to rho L by A. Got it? R is equals to rho L by A. Are you getting this point?
Yes, sir.
Okay. R is equals to rho L by A. Next is if the wire is stretched. If the wire is stretched, for example, if the question is being asked that if a wire is stretched to double its length. So when we are just stretching the wire, that in that case, the wire when stretched, it's also become thin. So its area of cross section also changes. So what it does not change is the volume. Okay, so when this is the normal formula, when the wire is length is doubled, tripled, or the area is halved, radius is halved, we're going to discuss the question regarding to this one. But if the word is used stretched to double its length, okay, then we use this formula R is equals to L square by V, rho L square by V. This is for stretching in case of wire is stretched. Okay, so this formula is used in case of wire is stretched. And let me explain you that why it is being used. Actually, you know that rho L by A is resistance. Okay, rho L by A is resistance. But when a wire is stretched, so you know that its cross-section area is also getting reduced. So for example, if it is stretched to double its length, then its cross-section area is also stretched. For example, if it is stretched to triple its length, then what is that thing that is going to be constant? That is volume of the wire will remain constant. So how can we convert this this for the volume? Here, this represents the volume of the wire. Okay. So this remain constant. Okay. So if I'm having the area here, if I multiply this with length, because area into length is volume. Like for example, this is the cylinder. And if you are having this area pi, volume of cylinder is pi r square h. So this is pi r square is area of base and h is height or length. Okay. So if I multiply this one with L and also the above one also with L, so this formula will become rho L square by V. So, but this formula is only being used in case the wire is stretched. Okay. When the word stretch is being used. Okay. Got it?
Yes, sir.
Got it. Next formula that we're going to use is series and parallel combination. Okay. In series and parallel combination, if we have the same resistors, and n type of same resistors are there. For example, five resistors are connected in series of same. They are same resistor. Then R total or R equivalent in series. We are talking about in series. Everybody note down this one. Okay. Then it will be N into R each. For example, there are 6 ohm, 18 resistors are there. So what you are going to do? 6 ohm, each of 6 ohm, 18 resistors are connected. Then you have to multiply 16 into 18. Whatever you get, you will get that equivalent resistance. Okay. But for example, if they are connected in parallel, like 18 6 ohm resistors, each of 6 ohm is connected in parallel. Okay. They are connected in parallel. This is 6 ohm, this is 6 ohm, this is 6 ohm until 18. So you will start you need not to do like 1 by 6 plus 1 by 6 plus 1 by 6 up to 18. No. What you need to do here is you have to find that R equivalent in parallel will be equals to R each means the resistance of each resistor divided by L. Okay, got it? For example, 18 6 ohm resistors are connected in parallel. 18. So you will do 6 ohm if each means the resistance of each resistor is 6. And how many are there? 18. You divide it, you will get 1 by 3. So that is 0.33 ohm will be the equivalent resistance. Okay. Got my point?
Yes, sir.
Okay. So this is very important that you need to do this one. Okay. And you have to note the formulas of each and every topic. Okay. Let's move further. So otherwise, you know the formula of calculating this series. This is R1 plus R2 plus R3 and so on. And similarly for R in parallel, 1 by R in parallel is equals to equivalent will be 1 by R1 plus 1 by R2 and so on. You can do like this. Okay, this is got it. Got it.
Yes, sir.
Now Now moving to the next part is next type of formula. The last formula of that we're going to have is the power, and power is P is equals to VI. Okay, but if in term of resistance, I is not given to you, but what is the formula for the power in terms of resistance? But I means resistance and voltage. Okay, so what's the formula? P is equals to V square by R. How I get this formula? So you know that V is equals to I into R. Okay, then I place instead of I, what's the formula for the I? So I will be V by R. This R will goes down. So in place of this I, what you will write here? You will write V by R. So you when you multiply, you will get V square by R. So this is the next formula for power. And the after this one, we're going to have uh, after this one, we'll have to have next formula, that is P is equals to I square R. Okay, got it? Got it? So these are the formulas that we're going to use. Okay, so these are the formulas that we are going to use. So everybody clear this one?
Yes, sir.
So let's move further. This is very important. So let's look. I is equals to Q by T. I is equals to NE by T. Because we can say that Q is equals to N into E. We have V is equals to W by Q. Okay, this formula. So these are the formulas that we are going to use. Okay, the next is the SI units. SI unit of charge. Charge is charge. SI unit of charge, or the symbol that we're going to have if charge is there. So we denote it by Q. Okay, and it's SI unit or symbol. Unit or symbol is actually coulomb. Okay, and for I, for current is represented by I, and its SI unit is ampere, and it's going to have A. For example, if current is represented, so it will be written as 5 ampere. A will be there, capital A. Okay, then we're going to have next is resistance. Resistance is represented by R, and its unit is ohm. Symbol will be there. For example, 5 ohm is written, means it is resistance is being given to you. Okay, the next is we have voltage. Okay, so voltage or potential difference, this is denoted by V. Okay, and symbol is also V. Okay, and next one is after this one, we're going to have power. Power is represented by P, and it is denoted by watt, W. Okay, and time is seconds. Okay, you got it? Understood? So these are the units, and one is conversion. 1 milliampere is equals to 10 raised to the power minus 3 ampere. 1 micro, like it will be written like this. 1 microampere is equals to 10 raised to the power minus 6 ampere. Okay, so noted this one.
Just a minute, sir.
Ammar, Saima, noted?
No, sir.
Yes, sir.
Okay, so these are the important things that you need to carry forward for this one, and these are the basics of this chapter. That okay.
Noted, sir.
Okay, so let's move further. Now let's proceed to the question that we'll get. For example, here it is being given to you energy. No work done is being asked. So here it is being asked that how much energy of each coulomb. Each means, what does the word each means?
1
1
coulomb.
coulomb.
Coulomb. Okay, so here coulomb means charge. So Q is 1 coulomb. Okay, first, whenever we are just going to solve any numerical, then we have to first write the information that is being given to us. Okay, that is called biography. Okay, so the Q is given 1 coulombs of charge passing through a 6-volt battery. So what is volt? Battery is potential difference. That is 6 volt is being given to you, and everything should be written in their SI units. Okay, for example, if milliampere is being given to you, then you have to convert it into ampere. Okay, it should be given according to the standard units. Okay. If, for example, in minutes is given to you, are you getting my point? If, for example, minutes is given to you, then you have to convert it into
Seconds.
seconds. Okay. Otherwise, your question will be incorrect. Okay. So, and which formula you will use here? Tell me. How much energy of each Coulomb charge is passing through this battery? So, which formula will you use? So, E is equal, you need to calculate E. So, what is the formula for?
V into Q.
Yes, E is equals to V into Q that we have discussed here. You can check. Okay, energy is equals to V into Q. So this simple formula we have to use and we will get the answer. So this is the NCERT question, in textbook question. So this is very simple question. So E is equals to V into Q. You can calculate. So E is equals to V is in the standard unit, 6 volt. Q is also in the standard unit 1. So what's the standard unit for energy? Tell me. What's the standard unit for energy?
What?
Joules, joules, joules. So we will use 6 joule. Okay. Got it? The 6 joule will be the answer for this question. So this is simple. Okay. Should I move to the next question?
Yes, sir.
Next, moving to the next part is, next question. Here, we're going to have this question. In series and parallel combination, you have studied different types of questions. Okay. So first of all, when you are going to calculate the equivalent resistance or equivalent, okay, current in the circuit, what you need to do is, whenever there are two resistors that are connected in series, then do not assume that they are in series. Assume that they are a single. For example, one 5 ohm resistor, one 3 ohm resistor, one 2 ohm resistors are connected. So assume that it is a single of 10 ohm resistors, and then do the calculation according to this one. So let's solve this question. This is a question example from the NCERT. In figure, it is being given to you that the R1 is 10 ohm. Okay. R2 is 40 ohm. And R3 is 30 ohm. And R4 is 20 ohm. Okay. And R5 is 60 ohm. And they are connected across a 20 volt battery. Okay. Is connected, and then calculate the total resistance of the circuit. So that's very simple. Calculate. First of all, you need to calculate this one, that make it single resistor. Okay. Make it. How will you calculate the equivalent resistance of this one?
R1 plus R2, so 10 plus 40.
Yes. So you R equivalent will be equals to 1 by 10 plus 1 by 40. First, you will do like this way, because they are connected in parallel. Make them a single resistor first. Okay. Got it? Got it?
Yes, sir.
Got it? Next one is, what we'll do next? Tell me. How much is the equivalent resistance of this one? This is very simple question. What we'll do? We'll take the resistance LCM. We'll make it 40. 4 plus 1 by 40. You will add these two. Okay. So this will be 5. 4 plus 1, 5. You cut it. You will get 1 by 8. So 1 by R equivalent is equals to 1 by 8. So R equivalent will be equals to, you reciprocal this one to get R equivalent. So you reciprocal this one, you will get
8 ohm.
So 8 ohm, instead of using this one, use a single resistor of 8 ohm. 8 ohm here, okay? 8 ohm. And then ampere meter. And then again, these three resistors are given. Calculate the equivalent resistance similarly. You, Saima, everybody in the class, please do this on Ammar.
Sir, 10 ohm.
10 ohm.
10 ohm. Okay, how? 1 by 30 plus 1 by 20 plus 1 by 60. So what is the LCM? Here,
60.
60. So into 3 into 3 You will do this one. You will do 2 into 2. Okay. Got it? In order to make it 60, so you will get 2 plus 3 plus 1 divided by okay. So we'll get 6 upon 10. Sorry, 6 upon 60. You will get it 1 by 10. So this is 1 by R equivalent. 1 by R equivalent. Okay. Got it? Got it?
Yes,
Got it?
sir.
So this is actually when you reciprocal this one, you will get 10 ohm. Got it? So instead of these three resistors, use a single resistor. Imagine that there is a 10 ohm resistor here. Okay. 10 ohm resistor here. Okay. And this is a 12-volt battery here. Got it? Got it? Now, what is the total resistance of the circuit? Tell me. If this circuit is instead of this one, if it is like this, because this and this have the same value. Okay. So if I ask you that what is the equivalent resistance? Tell me what is the equivalent resistance?
18.
18. You, Saima, why are you not responding? And you, Ammar? This is R equivalent will be, yes, 8 plus 10, that will be equals to 18 ohm. Got it? So this is the way that you need to find out the equivalent resistance. First, if the parallel resistors are given to you, then convert it into these single resistors by calculating the equivalent resistance, and then add all the series resistor that you have got the equivalent resistance, because for the first two you get 8 ohm, so 8. For the last three you get 10 ohm. So just add these two because they have now been converted into series. Okay. So, and if I ask this, what is the current flowing through the circuit current? Okay. Yes. Tell me fast.
V by R.
Yes, V by R. What is V?
So 12 by 18.
Yes, so it is 2 by 3. Okay. So this is 2 by 3. Okay. So we have R equivalent is equals to R equivalent will be equals to I we need to calculate. I is equals to V by R. So what is V? V is 12 and what is equivalent R? Tell me. 18. So you got it by 6, you will get 2 by 3 ampere. Got it? Got it?
Yes, sir.
Now moving to the next part here is next question. Here we're going to have next question on your screen. An electric lamp of 100 ohm and a toaster of resistance 50 ohm and a water filter of 500 ohm are connected in parallel to a 220 volt. They are connected in parallel. This is resistor 100 ohm. Another one is of 500 ohm. Another one is of, okay. So we are going to have this. Tell me, what is the answer for this question? What is the resistance of an electric iron? Okay. Connected to the same source means of this is connected with 220 volt and take as much as current as all three appliances are taking. So first of all, you need to calculate its resistance. What you need to calculate? Its resistance. Okay. So if it is taking the same current, okay, that take as much as same current as the three appliances are taking. So how will you calculate? Tell me. How will you calculate? Any idea? The first method is that you calculate the current taken by all these three resistors when they are connected in parallel. So if this is 100 ohm, next one is 100 ohm, next one is 50 ohm, and the third one is 500 ohm. Okay. If they are connected in parallel, first of all, calculate their equivalent resistance. Okay. And then, okay, tell me, what is the equivalent resistance of this
1 1 by 100 plus 1 by 500 plus 1 by 50.
And what is this? What is
That
that
is
value?
16 by 500.
1 by 100 plus 1 by 50 plus 1 by 500. So what is the LCM of this one?
500.
Okay. So what is else? What is LCM here? Tell me.
500.
Okay, you have to multiply it by 10 in order to get 500. In order to multiply this one by make it 500, you have to multiply by 5, so about 5 and about 10. Okay, so you will get 5 plus 10 plus 1 upon 500. You'll get 16 upon 500. Got it? So 1 by this is R equivalent. Okay, so R equivalent is 1500 by 16. Got it? Got it? Now
Yes,
the next step is that it is saying that it is taking as much as current as the these iron is means these all three resistors are taking, means iron is connected and iron is taking as much as current as these all three appliances are taken. So first of the next step is you need to calculate the I and then calculate I and just equate that I for V, put the value 220 and then you can calculate the value of I. Other method is that don't calculate the I. If you calculate the I, it is a wastage of time because it is saying we need to calculate the R. So and it is saying that I is common in both. So we have the formula that for I is equals to V by R. Okay. And R equivalent for the three resistors we are just talking about. Okay. Got it? Are you getting my point?
Yes, sir.
Okay. And here I2 is this is the three appliances. I'm just talking about the three appliances that they are taking. Okay. This is the R equivalent for them and this is the V. And this is the what is this? This is the current taken by the iron, and it is also connected by same voltage. Okay, and we need to calculate this resistance. We need to find out. But you know that this current and this current has the same value. This current and this current is the same value. Means this is taking as much as current. So we can equate these two because if it is whatever the value of this one is equal to this one also, the current is taking same. We can say read it here that it take as much as current as all the three appliances are taking. Okay, so all the three appliances whatever they are taking here. Okay, so we just write it I is equals to I3 when the three appliances are taking the simultaneously is equals to V by R equivalent upon the I of the iron taken is equals to V upon we need to find out this resistance. Okay, V by R. But since these two are same, so we will equate these two. We will equate this two. We will get V by R equivalent is equals to V by R find out. We need to find out. Okay. And you know that this V is for both of them are same. Got it? For both of them, this V is same because this is also 220 volt. This is also 220 volt. They are connected with the same source. So what is R equivalent of three appliances? Three appliances will be equals to 1 by R equivalent of 1 by R equivalent of the iron or the resistance of the iron. Okay, and this you can reciprocal that R equivalent will be equals to R equivalent of three appliances will be equals to resistance of iron. Got it? Got it?
Yes, sir.
Or should I explain you one more time?
Understood, sir.
You Amar, you understood?
yes, sir.
And you Saima?
Yes,
So what we need to do here is what we get from this question, that if the three appliances are connected, okay, and there is another appliance that is going to take the same current, as the three appliances are taking from the same source, then calculate the equivalent resistance of this one. Okay, that equivalent resistance will be equal to this, the resistors of this one. So we can simply do here that if the current is same, so we can say that I is equals to V by R. Okay. Okay. And if I is same, V is same, so we'll write it R1. Okay. R1 and I is also same and V is also same. This is R2. And if these two are same, then this will be must that these two will be same. Because if these two are same, then this will be must. Same. Okay. So what we are going to have the answer for this question, that R equivalent is equals to 500 by 16 ohm. And then you cut it by 4. You can simplify it by 4. So when you cut it, you will get 4 for the 16. Okay. And what you're going to get here is 25 into 5, 125 na. Okay, so this will be the resistance of the iron. Got it? And what now he is asking that what is the current through it. Now he is asking current. So you can calculate that I is equals to V by R. So what is V? V is 220. And what is R? R is 125 by 4. Okay. So you can write it 125 by 4. And this denominator of denominator goes in the numerator. That we have practiced so many times. Got it? So whatever the value you are going to get, this will be the current. Got it? Understood, everybody?
Yes, sir.
Yes.
Okay.
Yes.
Next question. Here's a question. Judge the equivalent resistance when the following resistors are connected in parallel. Okay. You are not going to solve. Just tell me the answer that where between what will be the value, approximate value of this one? There is one or
Less than 1.
Than 1.
yeah, it would be less than 1, because if they are connected in parallel, okay, so the equivalent resistance in parallel will be always less than the least value of the resistor. So here the least value resistor is 1 ohm, so the answer will be less than 1 ohm. Got it? And in this one,
Also less than 1.
it will be also less than 1, because it is always less than 1. Got it? Next question. An electric motor takes 5 amperes 220 volt line. Determine the power of the motor and the energy consumed in 2 hours. Electric motor takes 5 amperes from a 220 volt. Do this question and please answer the question. Okay, are you calculating? That some of the students might do one thing here, that they will start calculating the power in in joules. Okay, sorry, watt. Okay, so if the time is given in hours, so you need to convert it into the seconds. Okay, so what you need to do here is, we have the formula for power. Power is equals to V into I. We have this formula. And what is being asked? Determine the power. First, we need to find out the power and the energy consumed in 2 hours. Okay. So first of all, calculate the power. Calculate the power. Power is very simple. You need to calculate. You need to multiply this two. Abir, why are you not responding?
1100 watt.
Yes, it will be
100,
110, 1100 watt.
1100 watts, yeah.
It will be 220 into 5. You will get 1100 watt. Okay. 1100 watt. This is power. Got it? 1100 watt. Now, if this is 1100 watt is the power. Now, what you need to do is, sometimes the students used to do that. They will start calculating the power in joules because it is the time is given in hours. So, if we need to calculate the energy, the unit of energy is joule as well as kilowatt hour. Okay, this you need to clear this one, that what is energy? Energy is also power into time. Okay, if we have power in watt and time in seconds, power in watt and time in seconds, then we will get the energy in joules. But if we have power in kilowatt, okay, and energy in joules, and energy, sorry, time in hours, time in hours, then it will gives you energy which is in kilowatt hour. This is the new unit of energy, that is kilowatt hour. So it is better to convert this means this time into, means it is not better to convert this time into 7200 seconds. Okay, then you multiply this into 1100. No, what you need to do is, power is given to you, power is given, convert it into kilowatt, because this is what converted into kilowatt. So 1100 watt in kilowatt is, tell me, you have to divide it by 1000. Okay, this 2 will be cancelled out. You will get 1.2, 1.1
Kilowatt hour.
and time is already given to you in hours. And time, yes, so it will be, the energy will be in 11.2 kilowatt, and the hour is, I multiply this time, you will get 2.2 kilowatt hour. Okay, so whenever
Yes.
this type of question is being asked to calculate the energy during the energy consumed, okay, so the standard unit for this is kilowatt hour, because in the reading in electrical meters or electrical appliances, we don't calculate it into joules. Okay, if it is being asked to calculate in joules, so first calculate in hours and kilowatt hour, and then 1 kilowatt hour is equals to 3.6 into 10 raised to the power 6 joules. So multiply this value with 3.6 into 10 to the power 6, you will get the answer. But instead of doing this one, no, never it is being asked. Examiner will not going to ask you. You have to write it into the kilowatt hour. So better is that you need to convert it into first power, convert the power into kilowatt, and the time, if it is given in minutes. For example, if it is given instead 100 minutes, 100 minutes. So how will you convert it into hours? So 100 divided by 60 hours. This will be, okay. Got it?
Yes,
Understood?
sir.
So how will convert minutes into hours? But divided by 60. You will get the hours. So whereas time should be, to note it down whenever we are solving calculating the energy during calculation of energy in kWh. Okay, the power should be in kilowatt, and time should be in hours. Okay, if it is power is given in watt divided by 1000, okay, you will get kilowatt. If time is given in minutes, so minutes divided by 60, you will get hours. Note it down fast. Next. Done?
Done, sir.
Done, sir.
Done.
Yes, you, Amar. Done? Still writing.
Done.
I will check your, please don't take the screenshot. I will check it later, okay? Are you taking the screenshots?
No, sir.
And you, Saima?
No, sir.
Okay. So let's move further. The next type of question that is going to come in your examination is this question. Now it is being given to you. An electric heater of resistance 8 ohm 15 ampere is serviced for main 2 hours. Calculate the rate at which heat is developed in the heater. Do this question. Electric heater of resistance 8 ohm draws 15 ampere current from the mains service from the service mains, okay, in 2 hours. Calculate the rate at which heat is developed in the heater. Heat is actually energy and power into time is energy. Okay. Heat is actually energy and power into time is also energy. So if you have the formula of power is V into I, so heat for the formula for heat is Vi into T. If you have a formula of power is I square R, then for heat, this formula will become I square R into T. And if it is being, means if the formula
Sir,
for
the
power
answer
is
is
V
2
square by
kilowatt
R,
hour.
then the formula for, yes, Simon, what you saying?
The answer is 2 kilowatt hour.
2 kilowatt? What's the answer?
2 kilowatt hour.
2 kilowatt hour. Okay. So yes, 2 kilowatts hour. How? What is it? Calculate the rate at which heat is developed in the heater. Okay. So rate, it is being asking that rate at which heat is developed. So rate means, for example, calculate the rate at which charge is flowing. So what does it means? Current is being asked. Calculate the rate at which charge is flowing means Q by T. Okay, are you getting my point? Are you getting my point?
Yes, sir.
That if it is being asked that the rate means what is being given to you, okay, what is being given to you, you need to, okay, if it is being given the rate at which it is being developed, so it means what you need to do here is that simply you have to divide that one. For example, it is being saying that I is equals to Q by T. Okay, so you know that rate of flow of charge is current. So if it is saying that calculate the rate at which charge is flowing, so it means indirectly it is saying that current, calculate the current. Okay, got it. So if it is saying that calculate the rate at which heat is developed, so it means it is asking heat divided by time, that is power, because power into time is heat. So rate at which heat is developed is power. Okay, are you getting my point?
So, sir, the answer is 1000 watt.
Yes, the answer is 1000. No, not 1000. You have to multiply this one. Okay, and then you will get P is equals to VI. There is no use of this one. 8 amperes current flows per seconds. Okay, so the power at which heat is developed, you need to tell it in the seconds, per seconds, the power. So power is actually P is equals to V into I. P is, sorry, you need to calculate R. R is given to you, na? So you need to R and I is given to you. So P is equals to I square R. So what is I? I is 15 into 15. And what is R? 8. Okay, yes. 225 into 8. Yes. 1000 watt per second. Sorry, per hour. Got it? Got it?
Yes, sir.
So actually rate at which heat is developed. This is power. Okay. Got it? So indirectly rate at which it is. So next question. Here's the question given to you. A 9-volt battery is connected in a series with 0.2 ohm, 0.3 ohm, 0.4 ohm, 0.5 ohm. Okay, and 12 ohm resistors. How much current will flow through 12 ohm resistors? Do this question.
There is 0.75 ampere.
So how will you do this one? Let's check. Whenever there is a resistors are connected in series, don't connect them individually. Sorry, don't assume that they are separated. Just consider that they are a single resistors of in which all of them are connected. For example, if I'm saying that this is the in series, the current remains same, but if I'm having a 10 ohm resistor here and a 10 ohm resistor here, okay, they are connected in series with a 20-volt battery. So never assume that this 10 ohm resistor is going to have current that is I is equals to V by R, that is V is 20 and R is 10, 2 ampere. No. Whenever we are just calculating the resistors in series, it means that consider the whole connected resistors in series as a 1. So assume that this is not a 2 ohm resistors, just assume that this is a 20 ohm single resistor. Okay. Now, if you even break this 20 ohm resistors, it's your choice. Break it in any form, whatever you want. You can have 1 ohm, this 20 ohm, okay, then 5 ohm, then 6, okay, then 6 and 4 ohm, okay, and then 5 ohm, and then 2 ohm, and then 3 ohm. It's your choice. You make them sum as total. Whatever the current, this 20 ohm resistor is going to have 1 ampere current right now. These all, if you break it into infinitely many small parts, they are going to have the same. Okay, so what we need to do is, whenever it is being said to you that there are some resistors that are connected in parallel, so what you need to do is you have to make them equivalent. First, you need to make them equivalent resistors, calculate the equivalent resistance. So this is 0.2 ohm, and this is 0.3 ohm. Okay, then this is 0.4 ohm, then this is 0.5 ohm. How much answer you get, Abir? How much answer? What's your answer?
0.7.
Okay.
0.75.
So you calculated this equivalent resistance of all?
Sir, since I will be common, we cannot take 12 directly.
No, 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 no. Because in in series, the current remains same. So first of all, you need to treat them as a equivalent resistance. Okay. So first of all, what you will get here? You will first calculate the equivalent resistance. Okay. So here the equivalent resistance will be, you have to add all these. Abhi, this is the second time you are doing the same mistake that we have done in the previous class also, and you are doing the same mistake. Whenever the resistors are connected in series, you have to add all these, okay? Are you getting my point? That is 13.4 will be the sum of these. When you add all these, you will get 13.4 as an equivalent resistance, and that I is equals to V by R. Okay. 9 by 13.4 will be the equivalent resistance current through this one. And whatever the current is flowing in this one, the same current will flow in this one, because this is the total current of the circuit, and in series the current does not divide. Okay.
Sir, but they're asking the current through the 12 ohm resistor only. Even then you'll calculate everything?
No, actually the problem is that they are calculating they are asking for the equivalent resistance for the 12 ohm resistors. Okay. If it is asking because in series the current remains same, so whenever we are just asking the current, then we have to always calculate the equivalent resistance and then divided by equivalent means we have to write potential difference. Equivalent potential difference should be divided by equivalent resistance. Okay. So if it is divided, whatever the current you get, you will get the current of means in each resistor, not in the 12 ohm. This is are they all going to have the same? Okay. And if I ask you that what is the potential difference in the 12 ohm resistor, because in series the potential difference divides, then what we will do first, we will calculate that what is the current flowing through this resistors, means equivalent current will be calculate. So that equivalent current will also flow in this one. And what is that value? That is 9 upon 13.4. This is I. And if I ask you that what is the voltage through it, so V is equals to I into R. So I is given that you have calculated 9 upon 13.4 into R. R is 12. So that will be the voltage that will be flowing through this one. Got it? Got it?
Yes,
Yes.
sir.
So there might be you need to practice. Okay, the next question. If the current I through a resistor is increased by 100%, then the power will increase by, tell me first. If the current I through the resistors is increased by 100%, then the power dissipated will be, how much increase will be there? 100%. Yeah. So, Abhi, what's your answer? So what is being given to you? Current and resistors is given. No potential difference is being set to you. So which formula you will use here? P is equals to I
I
square R.
square R.
Okay, now this is the original power of this resistor. Now P dash will be equals to, what is I square? I has changed to, means it is increased by 100%. So 100% means it get double. Okay, so we will say that it is 2I square into R. Most of the time students did a mistake here, is that they do like this 2I square and they will write like this. They don't open the, I mean, don't do the square of this one. So P dash will be 4I square R. Okay. And this is the original power. So we'll write that P dash is equals to 4 times the original power. Now it is, for example, if it is was first 100 watt. Okay. Now it has become 400 watt. 400 watt. Okay. So what is the increased? 100 is already there and 400 it reaches. So 300 it is being increased. We can say that 300%. Or you can write it increased is 300 upon 100 into original into 100. Okay. So you can carry it. You will get 300%. Okay. Got it?
Yes, sir.
Done. So you understood? Understood this question? Everybody? You Abhi understood? Ammar?
Yes, sir. Understood.
Okay. Wait a minute.
Sir, but here it can be taken as an increase by 400, right?
No, it
Since
has,
it's from
if it is not, it increase in power. That is 300% increase. Okay. If it is asking, the new power will become 400 watt. Okay. So increase is always when increase is being asked to, actually we are already at 100%. Now it has become 400%. So increase is 300%. Nah? For example, you have 100 rupee note already and I give you 300 more. So you are now at 400. So what is the increase? Na? 300 na?
yes, sir.
One more last question. Three 2 ohm resistors A, B, C are connected as shown. Okay. And each of them dissipate energy and resistant for the maximum power of 18 watt without melting. Find the maximum current it can flow. Tell me. 3 2 ohm resistors are connected. And each of them dissipate energy and can withstand the maximum power of 18 watt. Tell me.